Yes, now we commence the panel 1, safety of navigation. Dear panelists, please come up to the front desks. Yes, and Dr. Kevin, please. And Alex. Yes. So next, please. Yes, I am very honored to introduce three distinguished speakers and Dr. Kevin. Next, the first panelist and moderator of this panel is Dr. Shimizu Etsuro. Dr. Shimizu's presentation is a study towards the ensuring safe operation in mass world. He will speak about the issues involved in the ensuring the same safe operation of ships in such a mass and non-mass coexisting environment. Next, the second panelist is Mr. Alexander Hoffman. Title is the EU Reflections on the Interplay of Unmanned Vessels and Humans for Coastguard Operations. He will touch upon the EU works on mass and interaction between human and machines. Next slide, please. Yes. So the third panelist is Mr. Nakamura Jun. The title is the Achieving Safe Navigation with Autonomous Ships and Efforts Towards MEGURI2040 Stage 2. He will talk about the safety of navigation efforts from the view of the developing side. So, Dr. Shimizu, the floor is yours.
Good morning and good afternoon and good evening, everyone. I'm Etsuro Shimizu of Tokyo University Marine Science and Technology. Thank you very much for inviting me this very interesting seminar. So today, the title of my presentation is a study of toward ensuring safe operation in mass world. Efforts toward the social implementation of mass are conducted around the world, On the other hand, it is not realistic to expect all ships to replace the mass at the same time, and mass and non-mass will be operated in a mixed environment. In this presentation, I'd like to talk these issues involving ensuring the same safe operation of the ships in such environment. Next, please. The outline of my presentation like this. Firstly, I'd like to introduce our university. Maybe you don't know that our university, and also I'd like to introduce my research topics. After that, next I'd like to briefly review the current technology level related to mass from the viewpoint of colleagues. Next, I would like to suggest the importance of the role of the remote operation center. You know that. And now, as the discussion about the mass code and the remote operation is a remote operation center is required to that for the operation. So in that case, we would like to use a remote operation center for the safety operation. So, and finally, I conclude my talk. Next, please. Yeah, next, please. Yeah. So first, I would like to introduce our university, Tokyo University of Marine Science and Technology. The Tokyo University of Marine Science and Technology was established in 2003 by merging the Tokyo University of Mercantile Marine and the Tokyo University of Fisheries. The Faculty of Marine Technology, which is originally Tokyo University of Marine Science and Mercantile Marine, is a leading academic institution of marine and maritime engineering in Japan. At Tsujima campus, okay, it's okay. So Tsujima campus is located at the 2.5 kilometers from about 2.5 kilometers from Tokyo Station. And next, please. Yeah. As you know that MAS is an abbreviation for maritime autonomous surface ship systems or maritime autonomous surface ships is composed of the combination of the following systems: autonomous ship, remote operation center, and support services, and communication system. So, and you know that the autonomous ship is cruises autonomously and without human intervention. This means that autonomous ship equips the system that can recognize the objects and events and change the navigational course and speed depends on recognition results. Remote operation center monitors the situation of the mass and transmit the operation commands to mass when mass is needed. When mass is in unexpected situation. Since the purpose of this, purpose of using a system is to transport the passenger and the cargo, and so mooring is one of important work at the port. So autonomous mooring system and at the port is useful for this work. And also, and finally, and wireless communication system is also key technology to communicate between autonomous ship and its remote operation center. Yeah, next, please. And so my research, this is my research topic, research results, one of research results. So I have developed, we have developed this remote control center. So bottom of the left bottom top picture is our electric boat, and the center of the bottom picture is a remote control software of the we have developed. And also left one, right one is a screen of the remote control system of our research. Yeah, and also we use the wireless communication system, Wi-Fi or LTE, depending on the situation. Yeah, next, please. And also, and this is another research result related to math. So we have tested AI to develop the situational awareness system. Top three figures show we apply the image processing technology to the same pictures. And after that, after applying the image processing processing to the picture and apply and use the AI, and then the result, recognition result will be changed and depend on the processing. Yeah, and also we would like to find a useful method, a useful image processing method to upgrading the recognition results. And also, in the bottom three picture shows we have tested for to recognize the direction of the ship. You know the end. So, and we have trained the AI by using our own picture, photograph, and then we'll be able to display the result of the direction of the boat. Next, please. Yeah, next, I would like to talk about the coral legs and current technology. I would like to talk about the current technology level related to mass from the viewpoint of coral leg. Yeah, next, please. Yeah, as told before, yeah, mass consists of these systems: remote operation center and autonomous ships and communication system. And autonomous remote operation center is located on the shore side or ships, onboard ships. So, and in my point of view, that mother ship and small ships around there is an effective use for the Coastguard work. So, especially for the monitoring and secure to keep the ships security of at the sea. Yeah. Next, please. So now I would like to review the current situation of the discussion related to the mass and coral and mass. And so, as you know, that at the MSC 107 held in May last year, the group has considered the coral Rule 5 concerning a lookout and whether this rule is needed to be amended, and the group had to subsequently agree that there is no need to no such need as a colleague specifically refer to the vessel rather than the person. Subsequently, the committee agreed that there is no need to amend the colleagues as it could be applied in full to any mass. And next please. And also the committee did not agree with the proposal to undertake the comprehensive review of the colleague in this stage, at this stage. So based on these results, in my point of view, that mass has to be developed to comply the mass and colleague at the present time. So next, please. So now I would like to briefly review the colleague and colleague convention. So as you know, that colleague is a rule to be followed by the ships and the other vessels at the sea to prevent a collision between the two or more vessels. Colleague includes 41 rules divided into 6 sections. Especially colleague rule 3 define the type of vessels as follows. Sorry, next please. Yeah, like this. So, and you know that power-driven vessel, sailing vessel, and so on. Then, so you know that collision avoidance rule is different depending on the type of vessel. These type of vessels. The next, please. Yeah. So, and I have tested, as told before, I have tested the AI to detect the vessels. So, and this is one of the results of the AI to detect the object. So the current AI system basically only displays just boat, no information of the type of the vessels. And type of the vessel, I mean the power vessel and sailing vessel, something like that. So we need to another solution to recognize the type of vessels. And next, please. And also, you know that very famous problem and lookout. So Core Rule 5 defines how to conduct a lookout. So we in order to follow the Core Rule 5, we have to use the sight and hearing and any other as well as all available means to prevent the accidents. Yeah, next please. So, and for example, and this is a picture of that we have taken that. So in a human can recognize not only just boat, but also the movement of the vessel like this. And also human can detect the fishing, and left bottom figure shows a fishing net, and the center bottom picture shows the hidden blocks and something like that. And also a human operator can neglect the reflection of the sunlight and so on. But the current AI is a little bit difficult. So of course, and this is my limited knowledge, so maybe you know that the new technology that can detect this kind of system. So in that case, let me know about that. That's why I'm pleased with that. So we need a more aggressive development to recognize this kind of system, to this kind of situation. So this situation is very lucky for me that because I'm an engineer, so I still have a lot of problems to develop that. Anyway, yeah, and next please. Yeah, and then this is the rule 34. So and 34 defines maneuvering and warning signals like follows that one short blast and two short blasts and so on. So seafarer and who get on the board on a manned vessel, and if they use such kind of sound signal, expect to the proper recognized by other vessels. So in that case, and so in this case, so mass has to, in my point of view, that mass has to recognize that these kind of sound signal in order to avoid the accidents, and also has to be. Yeah, it's okay. Yeah, sorry. So therefore, and mass have to equip some kind of system, to know the to detect the sound signals. However, and it is difficult to recognize sound signals at the current level of technology, especially for whether the sound signal is a short blast or a prolonged blast or so on. So, yeah, next please. So now I would like to propose the new use of the remote operation center. So next please. Yeah, and my understanding in my understanding, the remote operation center is equipped has to equip to operate the mass and investigate for the investigation for the competence of the crew. And the investigation for the competence of remote operator has been started. As told before, it is difficult to replace what is equipped in what is required in correct by a system at the current level of technological development. On that hand, so we would like to assume the situation that remote operation center is installed, remote operator is present at the remote operation center, and the system to transmit the image and sound information obtained by the autonomous ships to the remote operation center. So in this case, the operation system, in this operation system, so human can help the recognition of the image and the sound signal and so on at the remote operation center. So I have a question about that. So this kind of system is complied correct or not? So we would like to talk in the near future, of course, the future problem. So we would like to talk about the lock is enough or not, something like that. Yeah. Yeah, okay, next please. So now I would like to conclude my talk. So in this presentation, as for before, the current technology has not been able to conduct a proper object and event detection and recognition at the same level as the seafarers, especially a function of the response based on the result of the object and event detection is not possible to compare it to it conducted by seafarers. So on the other hand, seafarers on board is a conventional vessel would expect a similar maneuvering for mass. So in my point of view, mass should have a similar ability as a conventional vessel operated by seafarers. So this kind of things is also in the same thinking about the whole of the world. I believe that. So and if lock can be considered as one of the function of the vessel to conduct a proper lookout, the technical requirement to realize mass will be lower. Yeah, I mean that. So we can use the operator at the remote operation center to recognize the sound signal and something situation or something like that. And of course, finally, and the competence of the experience of the remote operators of mass are essential for safe operation at the sea. So, yeah, thank you. And this is my end of my presentation. Thank you very much for your kind attention. Yeah, thank you. And so I'm a operator, moderator of this first session. So next, I would like to invite the next speaker, Hochman. Yeah, Alexander Hochman, and yeah, please make a presentation.
Morning, ladies and gentlemen. I'm very pleased to be here with you today. I'm pleased to be at this event here in beautiful London, and I would like to provide you here at this seminar some EU considerations and reflections on the interplay of unmanned vessels and humans. Warmly thank the organizers for this valuable exchange that has been enabled here again, and it's a much appreciated format, particularly in view of the advancements of technology and the progress that we've seen towards international regulation in the upcoming IMO MAS code. I'm Alexander Hoffmann, working in the European Commission, there in the Maritime Directorate, Maritime Safety Unit, and we are actively involved in the work on the IMO MAS code. So let me first give you a short overview about what points I would like to address in my keynote today. So these will be the use of MAS and Coastguard functions, the EU work and the considerations about MAS that we have had so far, and an aspect that I would like to stress on today, especially, that is the role and the continued role of humans in MAS operations. So first, to begin with, where do we actually stand from our view? Well, we observe there's a gradual technology development taking place for MAS. So, and we can expect these disruptive changes in business models and operations to come in the future. Not yet, maybe, but certainly at some point. So there's not yet certainty, full certainty about the term MAS yet. We've seen there's the 4 different degrees of MAS. So do we always address for all 4 degrees when we use the term MAS? Do we mean fully unmanned ships or higher levels of automation, or actually both? From our side, we do not consider MAS as a goal by itself, but as contributing to a scalable, safe, secure, sustainable, and resilient solutions by a set of functional requirements. And in this context, it is that interoperability will be key, also for the situation of mixed traffic with conventional ships. We are absolutely certain that cybersecurity is essential, as Professor Jones has outlined to us again. And we see the way forward as a way that we all need to cooperate and coordinate internationally to make safe MAS a true reality. As for Coastguards, we believe that we should try to better understand the use of commercial MAS. So where will commercial autonomous ships be deployed? How will they run? And this will be essential for us to react appropriately and know what we can expect, what we can encounter at sea. Anyway, there are some questions that from our side still appear open. So the MAS, what is it for? What are the drivers? What is the business case? And especially, what is the business case for Coastguards? We see that safety and protection of the environment are key drivers for the developments towards autonomous ships. Our vision is 0 accidents, 0 waste, and 0 pollution. These are the objectives of the European Green Deal, and they have also been translated for the transport sector in our European Union Sustainable and Smart Transport Strategy. For Coastguards, we can expect that there will be efficiency gains, and we also see that maritime surveillance will increase. But also for other Coast Guard functions, we will see changes. In the EU, when we talk of Coast Guard functions, we mean functions such as maritime safety, security, customs activities as well, law enforcement, environmental protection and response, maritime search and rescue, fisheries inspection and control, and many more. I will now look more in detail at autonomous ships for Coast Guard functions, and let me share with you some first ideas, please. We believe that MARS will be complementary to patrol boats, to drones, and all the other means that Coast Guards have at their disposal today. And what is probably key is that we should use MARS for those specific functions where their use is an advantage, an add-on, and works better than our current means. The construction and operation of one specific autonomous ship for all different Coast Guard functions that I named, so safety, security, customs, search and rescue, and so on. This is very unlikely. One ship is not likely to have the abilities to address them all. We rather expect that a fleet of many different small masts could actually cover one or two, maybe of these Coast Guards functions each, and a fleet of different masts will be able to meet all the situations that we can encounter at sea. The arrival of Mars would also have a number of possible benefits, and most important among these is certainly the easier operation. So these easier operation, it could enable 24/7 operations, and it can also enable increased maritime surveillance. Mars will also allow us to think of new concepts. For instance, today we have patrol vessels at sea and emergency vessels, but today they are coming from a port. In the future, we can think of other operational scenarios. Would it be possible to station out Coast Guards vessels out at sea and have them ready on standby for the next mission, for the next emergency that may occur? With Mars, we see a significant potential also for cross-sector benefits. So, for example, data sharing for marine science. This is something where we can be having the situation that we can have win-win situations. This way, not only Coast Guards benefit, but also other users in the maritime space. In this light, I believe we should look also more closely at the interplay between sea-oriented and seaside authorities, so authorities that go beyond Coast Guards. So by making use of these various synergies, Mars and Coast Guards functions may have positive impacts on all these dimensions, on safety, on security, surveillance, but also for sustainability. It is clear that not only Coast Guards may use Mars, but we will definitely need to be prepared also to encounter other Mars at sea. And this will actually lead us to a key question. What is safety thinking in a time of unmanned vessels? What options do Coast Guards have to remedy a situation? And to what extent is it their task? From our side, we do not have a general answer, but I think the best we can do is prepare for different scenarios. In the EU, for instance, we have positive experience with tabletop exercises for rare maritime incidents. So in these exercises, we play through a situation, for instance, that we have a loss of connectivity with the vessel. And what are the steps that need to be followed then, both from maritime industry side, but also from the side of authorities? We've seen this can prove very beneficial. Some first ideas for such future scenarios could be, well, no communication with a Mars out at sea over a long time, or a known Mars entering into a port, but without an authorization. Could be certain Mars with an unknown cargo. There's certainly many more cases we can think of. So when would then Coast Guards need to intervene? And how should they do it? Shall we just call the remote master, the master on board? And well, if we don't know where he is, how do we do? When do we need to intervene on site and on the vessel itself? And how do we do that? And how do we react if the mast simply does not react? How can we prevent danger from shipping, but also from the population on shore the marine environment, and these surrounding factors. From the EU side, we are contributing to the work on Mars with the aim to make Mars as safe as possible. In the EU, our work on Mars began on a wider scale in 2018. A governance subgroup for mutual exchange has been created, the high-level steering group ad hoc expert subgroup Mars. So this is a group where all different EU and EA member states sit together, and industry and research can be invited on specific agenda items. And together in this group, we have developed a set of EU operational guidelines for safe, secure, and sustainable Mars trials. This was the first step, and these guidelines have been presented in 2020, and you can find them on our webpage on the DG Move Maritime website Mars. The European Union also conducts studies on a regular basis, for example, on the social dimension of the transition to automation. In 2021, we've done that, but also our specialized European agency is active in this field, this Agency for Maritime Safety, EMSA, located in Lisbon. They also run studies and develop possible tools for the arrival of Mars. They held a Mars workshop, and they have recently published a new EMSA study on competences for Mars operators in remote operational centers. You can also find that one on the website of the agency EMSA. The EU is also active in supporting different research projects in this field. So, for example, the research projects Autoship and Aegis that have been concluded, and the newly started Seamless project. Moreover, the EU is contributing to the International Mars Code, and we have provided different sections here. We've provided submissions, always together with the member states, of course. This international and intersessional correspondence group by the Marshall Islands has been a key factor for drafting the Mars Code and making it a success, arriving at a first outline there, and we are looking forward to further exchanges in this format as well. From the EU side, we've also had Mars at different cross-cutting events, for example, at a stakeholder workshop that we've held on the seafaring profession recently in January of this year in Brussels. What has become clear from our many exchanges that we've had is that humans can be expected in many roles, and even in the future in the context of Mars, both for the manned vessels, but certainly also for the unmanned vessels. So just think about all these aspects, such as technology development, the testing and the trials, programming, navigation, and other functions of a Mars. Then points within the operations, overseeing a Mars as a shipmaster, as a remote operator, the other shipmasters surrounding an autonomous ship, the pilots, then people that are working in towing, they are also interacting with Mars. We have docking assistants, there's loading and unloading processes, there's VTS operators, and last but not least, there's Coastguard staff on shore and also on board at sea. So all these professions, we expect they will also in the foreseeable future employ many people, many humans. So it can be expected that even a perfectly independent autonomous vessel will still need to interact with humans in many ways. So what are the consequences of these points? Well, on the one side, humans will still be relevant, even for Mars in high degrees of autonomy, but humans will also have roles, for example, as a backup, then as a fallback option for safety of many autonomous ships. This can be in regular navigation, this can be in emergency situations, but it can also be in other situations that Mars encountered at sea. The humans will also continue to have a core role in the maintenance of the Mars, in services for passengers on board, and many other functions that are not related to navigation per se. So humans will continue to have an interaction with Mars, both on the shore side and also interaction with other vessels. So in consequence, we believe there needs to be an easy communication with an autonomous ships and also preparations for the case how to deal with the loss of connectivity. So it all comes back to we need a good and proper human technology interface. Having a bit more reflected on this human technology interface, how do we make such an interface possible to work well with seafarers from around the globe and seafarers that are serving on one vessel one day and maybe on another vessel another month? We believe it's core to standardize here, so to standardize this interface, to use the same terminology. So whatever mass such a seafarer may be in contact with, that we use the same terms when we think of the same concepts. It should also be visualized and communicated properly by the autonomous ships, which action the ship or the algorithms on the ship intend to take. So for example, we might perhaps need certain lights, indicators, sound signals also from an autonomous ship, and vice versa, the autonomous ship to recognize these signals from other ships. So this is not only relevant for computers, but also for the humans handling them. So for example, the pilots, the different seafarers, but also for the coastguards that are interacting with Mars. So long story short, we need technology that is sufficiently easy to operate. When we then look one step further about making the algorithms also react in certain ways, believe that for proper safe Mars, it's important that we have algorithms that are traceable, where we can understand the reasoning. So a logbook, which includes not only what the ship does, but also input values from these sectors, where the input values go through plausibility checks in real time, and other Mars actions that are recorded, so that afterwards we can also find out, why did the Mars behave in this way? Why did you turn left at that position X? Many argue that we also need a red button to bring a vessel back under human control. This is the point here where there's different views on it. And for me, this practically comes back, who do we trust more? Do we trust more in the algorithm working well, or do we trust more in the human working well? Can we say who is genuinely safer? Or how do we decide about such cases? How do we respond more accurately to emergencies? And who is better in handling uncertainty, limited information, and doing independent judgment in a situation that may be complicated, where not all data is available? So I see the seafarers' job profiles will change, but their job is unlikely to disappear. Mars will bring along new jobs, highly qualified jobs. The right skill set will be needed for education, modern seafarers' competences. We are looking forward to also engage further in this debate and exchanges. As we can see, further growth in transport is expected. We will probably actually need more humans, not less humans, in maritime in the future. There's also new use cases coming up. For example, the Mars feeder traffic in short sea shipping, in inland barges. Mars provide new opportunities to compete with truck feeder traffic. So again, maybe maritime transport may increase. So there's a right set of skills needed and a right set of knowledge, and this will remain key also in the future. We need a technology that is sufficiently easy to operate. We need the right set of skills and knowledge that will remain key, and we need technology that supports the crew well. In short, I would summarize it as we don't need an overload of information, but easy access to it in case it is required. We need easily understandable, safe, low barriers, and it to be meaningful, we need simple procedures that do not compete or contradict. A technology that supports humans well in its tasks and that removes them from monotonous, dangerous, dirty jobs and brings machines in where machines perform better. Would be night visions or other tasks where no fatigue can be observed. Then human-centered design. This is what keeps the tasks relevant to the crew and also lets the crews enjoy the tasks. So we need meaningful jobs also for the crews on board. So I'm looking forward to this to the discussion, to continue this discussion and to collaborate internationally on this. Let me just provide you with one information still that is about, we will continue this discussion also at a series of events which are called the International Ship Autonomy and Sustainability Summits. We've been running them together with Norway together since 2019. And we have been holding them annually at different locations. Last time was in Oslo. And we keep up there the dialogue between industry, researchers, test projects, and administrations. We are currently planning the next edition of this format. It will take place in autumn 2024 in a place that will soon be decided. And we expect to focus these discussions there in this autumn on the human-machine interface. I'm looking forward to see many of you there on that occasion. To conclude, we continue to see big potential in Mars. It has become clear that humans will, at least for many years, have important roles to play in the development of operations of Mars. And there's a good use case for them in Coastguard functions as well. Let's explore this further together. Thank you very much for your attention.
Thank you very much, Mr. Alexander Hoffman, and a very interesting presentation and include a lot of topics of that. So later we'd like to talk about discuss about that things. Thank you very much again. Yeah, thank you. So next, so I'm sorry I explain about forgot to explain about that. So firstly, we will make a presentation and all presenters. So after that, we have a time for a question and discussion. So please wait about the question. Of course, you have a lot of questions about that. So please wait few minutes, yeah, 20 minutes or something like that. Yeah. So next, I would like to invite the next speaker and Captain Jun Nakamura for the presentation about that. So he'll present about the MEGURI2040 project in Japan. Yeah, please start the presentation.
Thank you very much. So good morning, good evening, everyone. So I'm Jun Nakamura, MTI. So MTI is R&D arm of the NYK line. So originally, I'm master of the NYK line. I boarded to the several kind of the vessel in the NYK line. So LNG carrier, container vessel, LPG carrier, PCC like that. So I have the many kind of the vessel boarded. So thank you very much for the good opportunity to introduce to our project. So today I will introduce to the MEGURI2040 stage to our development and achieve to our safety operation. So our outlines are like that. So firstly, introduce to the MEGURI2040 stage 2 and the development system in MEGURI2040 stage 2. Then next to the evaluation and verification for the environment in our project and our challenging and our future. Then lastly, the summary. So firstly, introduction to the MEGURI2040 stage 2. Yes, in our view, the need to the autonomous vessel is improved to the safety operation and so countermeasure to the shortage to the seafarer and to make the transportation environment more robust. In terms of the environmental operation, currently 80% ships operation accident caused by the human error. On other hand, increasing size of the vessel has reduced to the ship's maneuverability at present situation. And in other hand, so for example, the Singapore Strait, so now going to the more congestion area than before. So so reduce to the that's why so we need to the early action is very important for the seafarer. So then secondary, so number of the seafarer decreasing the seafarer. Now seafarer is decreasing. There are reported to the shortage of the seafarer worldwide, and this is more serious problem in Japan. The third is so changing transportation environment. Cargo that has originally transported by truck is now being transported by ship and railing. And shipping is expected to increasing in the future. So it is important to create an environment in which the vessel can firmly implement transportation in such case. So MEGURI 2040 began its stage 1 in February 2020. And as we introduced to the last year, so in March 2022, the first project achieved approximately 29% autonomous navigation during the demonstration from the Tokyo Bay to the Ise Bay. So stage 2 started in October 2022. With the project goal being to the commercial operation for the autonomous vessel. While stage 1 is limited to the demonstration only, so stage 2 it's advanced to the development autonomous vessel that can be continuously used for commercial purpose while complying with the current regulation. So in MEGURI 2040 stage 2, efforts are being made both technology development and the construction of the social infrastructure with aim to implement autonomous vessels in socially. So in technology development, the project working to the demonstration test using to the 4 vessel, and we are making to the industrial standardization for autonomous vessel, and the construction of the development process and product out to the each equipment. So in area of the social infrastructure development, the project is working on the regulation studies, economical verification, and the construction and education of the technology for the ship's operator. So I would like to introduce to our outline MEGURI 2040 stage 2 DFAS Plus project. So MEGURI 2042 stage 2 is a 3.5 years project with the duration of the October 2022 to the March 2026. So consortium members of the MEGURI 2024 stage 2, currently 52 companies joining to our project. And so our company, MTI, is project management office in this project. So next is the organization of our consortiums. So with the support of the Nippon Foundation, the DFAS Plus consortium structure is being complied as a whole by P project management office and consists of the 3 working groups. So first working group is a demonstration working groups. Then second working group is a standardization working groups. And finally, so social implementation working group. The consortium will also working closely with the ship classification like Plus NK, Lloyd Register, DNV, ABS, like that. And so government agency also. So this is to realize to the social information interactive. So a demonstration working group consists of the one newly built autonomous vessel and 3 elementary technology development vessel for autonomous. So a standardization working group is divided to the 8 sub-working groups for preparation to the standardization required for the autonomous vessel. And currently, we are preparing to the white paper for the standardization. And this white paper will produce and proposed to the ISO to or IAC. So this section distributes the voyage of our demonstration vessel from north side. So our Ro-Ro vessel will sail between the Kushiro and Hitachi. This is one of the elemental technology vessels. Then full technology vessel is a newly built container vessel, so between Tokyo to the Osaka Bay. Then elementary technology vessel is converted container vessel. This voyage is from Nagoya to the Kobe. And finally, so outlying island route vessels. So that route is from Okayama and Shodo Island. So the demonstration period will be last up to about 9 months with cargo on board and is planned to cover to the bus-to-bus operation. So the navigation system designed to achieve to the autonomous operation level 4 in the demonstration. And while the engine system designed to operate with the remote monitoring by a shore chief engineer and one working onboard engineer. So we set the one engineer's operation. So next is the soil development system as in MEGURI2040 Stage 2. So in the first time, so in DFAS Plus project, we fixed the autonomous systems, autonomous status and navigation mode. So this is very important item for us. This is a very flexible response to each navigation environment and ship's equipment and surrounding to the condition. For example, in the berthing and unberthing time, we not only rudder and engine control, but also thruster control is required in the berthing and unberthing operation. But in the coastal operation and ocean operation, use of the thruster is not required. So availability of the thruster is not necessary requirement for the determine to the autonomous status. That's why so each location we fix each status, then we'd like to flexible to operate to the autonomous vessels in present situation. So next is our development items. This section distributes the specific development in the navigation side. So in navigation system, we developed the new sensor function for the integrated and analysis sensor information and function for the planning voyage and function for the controlling to the vessel are being developed. So in engine system, we are developing to the function for the detecting and remotely monitoring to the abnormal situation in the engine plant. We are also developing to the function to the manage the status of the autonomous navigation system, and so record to the information from the autonomous navigation system. This is very important. So when we occur to any accident, we must reporting to that information also. So then ship to and shore communication that take with cyber security and account have been established. So enabling to the ROC remote operation center, formulating to the long-term voyage plan, monitoring to the autonomous navigation system, and monitoring to the engine plant. So this diagram is respected the component in our autonomous navigation systems. Firstly, information gathered by the various sensors integrated by the integrator. So then, and the planner designed to the collision avoidance route and docking planning also. So then finally, controller, which is we said to the drivetrain controller, is controlled to the rudder, engine, thruster to manage to the ship's movement. So this is not same as a dynamic position system. So we are controlling to the high speed range to the low speed range. So in MEGURI2040, we're also to use the function development to review to the navigation duty. Especially currently, so 2 persons required on duty on the bridge. on the large vessel at all time. In step 1, we will examine whether it is possible to have one person on navigation duty. And in step 2, we will examine whether bridge 0 is feasible within the ODD. We intend to achieve this replacing most of the navigation tasks currently out by the navigator, helmsman with machine. And by the establishing to the system in which people carried out the checking and approve. To give an example, for the information gathering is currently carried out by the navigation officer or lookout people. And to various checking, radar manual plotting, and chart checking also. But this will be replaced by the automatic radar plotting by machine and information gathering by the camera sensors. The specific will be explained in the next section. So firstly, I would like to introduce our development sensor items. So firstly, image recognition by the camera. So object recognition rate is over 90% at present. Then 36 object tracking is possible. And improve the object recognition performance by the AI. So we are trying to make the more good performance continuously. Then next is automatic data information acquisition. So our current operation, manually plotting by the ship's operators, like a navigation officer, master is carry out the manual plotting in the radar. But false image occurs in the radar, also confirmed by the navigation officer. Then navigation officer checking, this is false information, this is true information, like that. So in the MEGURI2040 stage to the development items, so TT target tracking is automatically carried out by radar. And so machine will be removed false image also. So we are now trying to make a development. So next is the integrator and information analysis. So our current operation is a collision hazard assuming to the seafarer's mind analysis. But the MEGURI2024 stage 2 items, so machine calculation and visualization, the information is necessary for the collision avoidance hazard. Then next is the alert due to the change of the bearing. In the current operation, so collision risk analysis in which seafarer regularly measured the change to the bearing heading on the other vessels. So in our development items, machine sees to the changing to the heading, and so if we find any dangerous situation, going to the alert to the best ship, and so inform to the system side and the navigation officer side. So next is our planning item. So in our current operation, master and navigation officer formulate to the collision avoidance plan based on the information gathering and analysis. But our development items, so machine drawing up to the collision avoidance plan based on the information collect and analyze. So in the present, our development item. So and automatically sent to the execution function or asking to the approver for the good route or bad route for the approval. So then finally in the DFAS Plus, we are developing to the drivetrain controller capable to the controlling to the high speed to the low speed range, including to the berthing operation. So during development, we are create to the simulation model based on the data collecting from the model examination. And so connected to the simulator to the drivetrain controller and work on the building to the function and improvement performance. So in the remote monitoring to the engine plant, we are developing to the system that allow to a single marine engineer on board and shore chief engineer is checking to the multiple vessels. So we are identifying to the necessary development for the autonomous navigation systems of the vessel and engine plant of the vessel, and the remote monitoring and control system. And we are advanced in the development so that these function. Now, that function is now we are making to the new development to the new functions. So next is our evaluation and the verification environment. So to evaluation and verified systems being the development. So development process will be continue to use to the V process as in the DFAS project. We will create the concept of the operation from the use case, required functions, and the equipment configuration. And based on that information, we will carry out to make to the concept design and risk assessment also. This time, we will use to the method of called the STPA analysis. So to analyze to the accidents that occur within the continuous interaction of the each subsystems, we will identify loss scenario and various constraints, which will then to be connected to the basic and detailed design. So loss scenario created here will be analyzed for the overhaul systems testing. Furthermore, during basic and detailed design phase, we will perform risk assessment for each individual subsystems using a risk assessment method called the FMEA. And the result will be integrated into the scenario for the unit testing. So challenge and our future. So through this project, we are committed to social implementation autonomous vessels. When it is come to achieve to the safety required as by rule and environment, we believe a critical point to develop with a clear understanding of the characteristic to the both human and machine to ensure safe operation as required by the rule. For example, so while machine excel in the accuracy and parallel processing, they may lack in the flexibility and the reliability, which are characteristic where human is excellent. When applied to our current operation, machines are capable continuous 36-degree monitoring of the multiple vessels. However, when it comes to unclear information, human can respond information prediction and our experience, which can be changing for machine. Hence, human support become necessary. In the future development, by covering this unclear information into the clear information, we can advance to the higher levels of autonomous ships. As a result, we will work toward to the improvement of the safety navigation. So finally, my summary. So we started to the MEGURI 2000 Stage 2 in October 2023. So DFAS Plus is so working on the development technology and social infrastructure for the social implementation for the autonomous vessels. In order to achieve safe navigation and of the autonomous vessels, new knowledge will be incorporated in the open collaboration to promote the social implementation. So thank you very much for listening to my presentation.
Yeah, thank you very much, Captain Nakamura. Very interesting presentation and the introduction of the MEGURI 2040. So now we would like to move to the Q&A session. And so any question, comments from the floor about the presentation? Yes, please.
Hi, my name is Nick Reynolds. I'm from BBC Monitoring. I'd like to ask Professor Jones a question, which may be an unfair question, and I completely understand if you can't answer this. I thought your presentation was fascinating. My question is, has anybody tried this yet? Has anyone, any group, any hostile actor, any terrorist or extremist group tried this? That's why I'm saying you don't have to answer it if you don't want to. Yes.
Let me give the easy answer. Certainly at the cybercrime level, there is evidence of existing activity. Many of the major shipping companies have been hit with targeted ransomware attacks. There's public knowledge that certain state level actors have been involved in, let's call them cyber incidents involving sort of military assets. They've been reported in various venues. In terms of sort of specific terrorist activity, in terms of shipboard systems, there's nothing publicly announced that I'm aware of. But certainly if you look at critical national infrastructure in terms of things like pipeline, energy production, there is evidence of attacks in that space. So, you know, it's not too far a stretch to say it is pretty certain that these things are being looked at.
Thank you very much.
Thank you. Just a moment, please, and please change the slide for that, because the presentation that the presentation is displayed on the screen. Please change another slide on the maybe a program or something like that. Yeah. Yeah, sorry, any question? Yeah, please.
Thank you. I also wish to ask to Professor Kevin Jones. Thank you very much for your very interesting presentation, clearly articulating the potential risks of maritime cybersecurity issues, and we realize the grave impact caused by such incidents. So I'm from Japan Coastguard Maritime Security Group. And not so much discussion is made in my Coastguard regarding this issue. Could you suggest to us, if any, what role should be played by the Coastguard in the process of preventing and responding to such maritime cybersecurity issues? Thank you.
I think that's a very interesting question at a number of levels. And depending on the role of the Coast Guard in various different environments, you get different answers. If, for example, we go to one extreme and look at the US Coast Guard, the US Coast Guard are the regulatory authority for cybersecurity in the maritime domain. So their roles range from setting regulation through to active intervention in sort of the case of seeing incidents. In other situations, the UK and Japan, I think the Coast Guard role is very clear in responding to certain incidents. We've run some tabletop exercises with a number of groups, including a particular National Coast Guard, where the scenario under discussion was loss of control of a vessel due to cyber attack and imminent physical damage. At that point, sort of the interesting questions were, do existing protocols and operational procedures, which would result from equipment failure or malicious crew action or whatever, do they cover the kind of incidents that a cyber attack may cause? In that particular case, the answer was no. There were things that hadn't been thought about sort of in that context. In other situations, it's been the case that cyber is just an instigating mechanism that gets to a scenario that is already well covered by existing practices and existing regulations. So I think the question in detail would depend on exactly the authority and responsibility of the Coast Guard in certain scenarios. But we can certainly hypothesize situations where a physical response would be needed by the Coast Guard to a cyber instigated incident.
Thank you very much. Thank you very much for the good food for thought. Thank you for the Coast Guard. Thank you.
Thank you. Yeah, please. Sorry, backside. Yeah. Next.
Thank you very much. My name is Mehmet Ali Figüler from Turkish Embassy. First of all, I'd like to thank you for organizing that important event. I have two questions, if I may ask. One of them is the information provided via GPS or AIS. How we can trust, there are some issues about that. And then how we will confirm the information received from GPS or IS? Are there any extra methods for confirmation? The information received via IS and GPS. This is my first question, or maybe I can ask a second question later on, or can I ask now? The second question of mine is conclusions of the first presentation. The third one, it says, on the other hand, the seafarers on board a conventional vessel would expect similar maneuvering for mass. How you can be sure about that? Because situation, I mean, evaluation of the officer on watch could be different than mass, because they can see the situation, or how you can add the behaviors of the officer of watch to the system, and also communication between mass and in-person ship. How you can achieve that? Thank you.
Thank you very much for your question. So firstly, and what I like to ask questions. So first one is, yeah, of course, AIS and GPS is, and also as information. So for example, now it's discussing about the VDS and something like that. Yeah, of course, we need another system to recognize our situation. But in order to install that in a real field, we need we need to discuss at the regulational side or IMO or something like that. So in that case, we need long time discussion about that, especially for we need agreement of that in the world. So of course, so now I'm a technology and engineer, so we propose a new system to communicate each other. But regulation point of view, that install that kind of system is that we need a long 10 or something like years for the install that. So, but that's a point for that. Anyway, and this is one solution of that, but the capacity of the communication capacity of the AIS is very limited. So we need to support another system to follow the AIS. So in my point of view, AI is not enough for that, especially for the mass operation. We need another solution. But the answer and solution is not, I don't have the enough information and enough technology about that. So we need more development of that. And second one is, of course, important. And so how to evaluate the system ability of that to compare with the human is one important problem. And we need to develop such kind of evaluation system for that. Of course, in Japan, we can, including one of the topic of the MEGURI2040, we have checking about something like that. We are preparing such kind of evaluation system to compare the human seafarers on board right now. So, but now we are still finding what kind of skill is important for that. So now we are collecting currently we are collecting data, how to evaluate such kind of system. So we are, of course, if you are interested in that point, so we would like to collaborate with that. Of course, in Japan is one of the company, but on the operation of the ship is worldwide. So we need about collaboration that. So in the future, we would like to discuss about that. Thank you very much. Thank you very much. So any other question? Sorry, yeah. Please.
Well, thank you, Professor. It's a question for you also. It's just to ask you if, in your opinion, the Rule 2 of COLREG question of ordinary practice of seamen can be translated to algorithm, or if it can be done. What is your opinion on this issue?
Yeah, of course, and thank you very much for the question. So of course, maybe possible to replace that system, but in that case, we need more years. So especially for the evaluation time is important for that system. Is we can we can use that or not. So such kind of evaluation is also evaluation time is important for that to use that system. Maybe and if we can evaluate and almost all seafarers agree to use the system and a computer system, in that case we will be able to replace that human to the system. That's my opinion on that. Thank you very much for your question. Any other question? Yes, please.
Thank you very much. My name is Mauricio Cruz from the Mexican Maritime Authority. I have a question for both Mr. Hoffman and Captain Nakamura. It's regarding the standardization and the dynamic positioning vessels. Because is it possible to introduce the technology of DP Class 3 vessels into the other type of cargo vessels like simply bulk carriers or container vessels? Because if we integrate the DP3 class propulsion system, positioning, and navigation with the classifications societies establishing a manual to have all in a standard between DP and cargo vessels.
Thank you very much. Good question. So our standardization working group, so we separate to the 8 sub-working group. So it is navigation side, we prepare to the 4 working group. The one is the sensor. Secondary is the integrator for information gathering. And so making the planner. Planner is so collision avoidance plan, long-term plan also. Then controller. That's why so this is not only the DPS systems. So we are separating to the each subsystems to making to this white papers. Then so this white paper including to some interface for the sensor to the integrator interface also very important for the standardization. And so integrator to the planner to the controller also very important. Then so in case the controller side, so for the autonomous like auto docking, so auto unbassing or like that. So what is the function requirement? What is the performance standard or like that? So now we are trying to make. But so this is not only to the module vessel or like that. So we are considering to the all merchant vessel and other working vessel also covering to that standard. That's why so we not only small wide the standard. So we like to open and the big making the big standard. Thank you very much.
Thank you for the question. Yes, the standardization aspect will be a key one, but I believe it is actually too early to address that in full. What we have with the upcoming regulation in the International Mass Code, we have set here a path for that, in that we define different functional requirements so that the different masts operated in all waters around the world do not work completely different, but have, let's say, comparable logics according to which they are designed. And that is still far from standardization, but standardization will much depend on the technical side as well, as we've just heard. So to take this then to a more political level, I think it is too early to tell.
So please, next. Yes, please.
All right. Thank you so much. My name is Wala William from the Nigeria High Commission. Perhaps maybe this question is for all of you there. With the prevalence of piracy in various regions of the world, Gulf of Guinea, would you say autonomous vessels is the game changer? Just inquiring if that would be a solution to lots of those challenges. Thank you so much.
Yes, thank you for your question. So, may I ask you to answer that? Well, please. Yeah.
Thank you very much for the question. So yeah, I have the experience to the meeting to the pilots also. So that's a very serious problem for me also. Yeah, for that in the presently, so the autonomous ship is not a big good solution for the countermeasures for the piracy. But in case that we are connecting to the remote operation center to the vessel side is more deeply. So vessel in the shore side, very easy to understood to the present situation on the vessel and so in the future case. So shore side can control to the emergency operation to the vessel side. This is so I think good quality for the countermeasure to the piracy. Then in the future, so I think this is the long-term future. So in the if a crewless vessel or something, so we can change to our vessel's shape or something. So we don't prepare to the pilot radar. We don't need to prepare to the any access point for the vessel. So in case of very piracy, difficult to coming up to the vessel side. This is, but so maybe so this is so long term future. I think. Thank you very much.
Any other comments, please?
Making a comment on that. I think we're already seeing the emergence of sort of cyber-assisted piracy, you know, being able to sort of spoof a vessel's location, being able to potentially influence a vessel's location with things like GPS spoofing. I think at the moment, the assumption is that the crew will at some point notice and take appropriate action, hopefully before there are people physically coming on board the vessel. But as we move more and more to autonomy, the likelihood of noticing such actions early will become less. So I think it will, as was just said, the idea of changing the fundamental design of the vessel to make current piracy much more difficult will actually be a solution that isn't available today. On the negative side, the ability to influence the vessel in ways sort of primarily driven by cyber are possible in ways that aren't possible today. So like many things about autonomy, it'll be a gain on one side of the sort of scale and a loss on the other side. And I think we couldn't yet say where that's going to balance out.
And this is absolutely my perspective on it as well. We will see a change in piracy, but it's unlikely to assume that piracy will just disappear. So is it a game changer? Probably rather not. It will change the face, and it will be a different kind of problem. But it will still be there, and maybe it's also occurring not in the same regions as we do have it today. But how can we tell? Also, the remote operating centers, they will face new challenges, and knowing that what they see on screens, on sensors, is actually what is coming right in from the vessels, or whether this has also been influenced by outside actors. So it will be difficult to identify such a situation early on. And so a different piracy will still be around, I think so.
So I would like to answer another point of view that, so of course, this is a work seminar organized by the Coastguard. So maybe a Coastguard mission will be effective use for that. If Coastguard use autonomous vessel, unmanned vessel, they can cover a lot of area of that. So in order to cover the, and in order to monitor the area and guard the area, guardrail will be expanded for that by using autonomous vessels. That case will be covered. That another point of view that you have to use the autonomous vessel for that. That's my idea of that. Thank you. Sorry. Any other questions and comments? Yes, please.
First, thank you very much for a great presentation. My name is Takashi Hongo. I want to ask about the expected role of pilots, human pilots. If vessel is controlled by remotely from the operation center, do do you or does the industry think that the pilots are still necessary, or do you think the role of pilots will be diminished in the near future? And if yes, so if you still think that pilots are necessary for some duration, well, how can pilot assist the vessel which is working under which is working remotely?
Yeah. Okay. Thank you very much for your question. So maybe we ask maybe, and of course, you can.
Thank you very much. Good question. So I'm also a master mariner. So maybe so in the future I'm promoted to the pilot or not. So I'm not sure. But so anyway, so it's a good question for us. Thank you very much. So in the autonomous ship, so now we are trying to the coastal vessel and the small size of vessel. So normally pilot don't onboard to that kind of the vessel side. Then in the future, for example, NYK line will change to the autonomous vessel. At this time, so in the control matter, so we can very difficult to the control by the vessel size only. So if we load it the big thruster and or agiport or something, we are very become big cost. Maybe so we must support to the berthing operation with the tugboat or something. So that's why so pilot assistance is very important in the future, I think, for the big size of the vessel in the future. Then in case so we are making to the remote operation center and autonomous vessel. So for the pilot assistance style will be changed is possible. I think possibility. For example, the remote support by pilot from the remote operation center to the vessel. So vessels, autonomous vessel, the captain on board, so manned to autonomous. So then remote operation pilot will be coming to the remote operation center, then support to the onboard master. Also one of the type of the new pilot's activity, I think. Thank you very much.
So speaking as an academic researcher now, one of the interesting questions there is if you're building an AI system to control an autonomous ship, is that system the same in the sort of environment where a pilot would normally operate as it would be in open water? So for example, even if you were, and I think this is a long way off, to assume there would be a level of trust that didn't require a human pilot on board in the kind of circumstances where we require them today, I think it's an interesting technical question of whether that's the same autonomous system as you have in other operations, or whether you sort of virtually onboard a pilot AI in the circumstances where you need them. So I think even ignoring the fact that regulatory, this is a long way out, I think technically there's a very interesting question about the level of training, the kind of training sets you would use for AI in that environment as opposed to an open environment. So it's a great question that can be answered at many levels, I think.
Yes, I also see that also in the future, the pilots will still maintain a core role in navigating the ships and assisting the ships in navigating and to the ports. And yeah, well, a pilot, the way it is now, this is probably not what we're gonna see with mass in the future. But well, as a pilot, also, he is the one who is most knowledgeable about the approach to a certain port, about local weather conditions, about situations that may be occurring, maybe other traffic that might interfere, or other local phenomena that both the remote operating center or any remote master may not know about. So I still believe that's a tremendous role for the pilots to play. Yes, in which form that is, this is what is a bit difficult to predict now. Will it be here an additional software tool that is then brought in? Is it here, as you heard, the same AI software? Is it a different one? How will this in the end go? So coming to the question of trust, it's also about the ship operators. Do they trust? Who do they entrust most here to bring the ship to the port safely and also when encountering all kind of circumstances there. So we can also maybe look at it from the other side. So from the port side, from the coastal state side, who does the port entrust to bring the ships, including the autonomous ships, safely into port? Is it that a remote operating center, perhaps from the other side of the world, is it trusted here to bring in the mass safely and not to block, for example, the port approaches in case of any emergency or accident that occurs? So I think there's different views we can have on that, and it's going to be a long discussion still. Next.
Yeah, so in my point of view, so my opinion is almost the same as any other presenters. So, and one of the work of that remote operator, maybe a pilot to become a remote operator, maybe something like that. Yeah, that's all work changes, work, how to work, where is the place of that? So a little bit different, but maybe almost, I think that almost same, and knowledge is required for that remote operator for that. So I think that pilot knowledge about the pilot is still important for that when mass is installed in the world. Yeah. Thank you very much for the question. So I'm sorry, and now it's almost time for that. So I'm sorry, and so we have a lot of questions from the online, but may I ask you the staff to keep record and the question from the online that later we will say, I check that we would like to make answer for that questions. So anyway, and this is the only, I'm sorry, I'm not well organized this panel session that, so this is the panel session, so we need to discuss with us about that. But we are very lucky for us, and so we have a lot of questions from the audience of that. Thank you very much for the audience about that. So, and finally, I conclude, and before I conclude this session, I think that all presenters, including the keynote speech from the Professor Kevin Jones, and topics is that human and technology interactions. So if the mass install the world, but we need still human knowledge about that. Not only the cybersecurity side, but also autonomous ship side. So to support the remote operation center, something like that. So in the future, we need to talk about more things about that and how to train human technology interaction is maybe include one of the part of the technology side, but also the how to train people, a human, to carry out such kind of job, conduct such kind of job that. So in near future, we would like to talk about such kind of things, how to train the human to cover such kind of technologies. So that's my the final talk about that. Thank you very much for it. So now the time is coming. So thank you very much for attending this session. Hopefully you have a good impression about this session. In the future, we would like to talk about more things about that. Thank you very much for attending. Thank you.